Today we're back in section 2.5. We started section 2.5 a couple days ago just by learning some terminology, and now today we're going to jump back into it and talk about what the section title actually says, apply the distributive property. I'm going to kind of showcase how this works, or one situation we might use it, and how we can go from one expression to the other using the distributive property by talking about this word problem here to get us started. It says Mike and Michelle are each planting gardens. After some thought, they decide to combine their efforts in order to grow more flowers. Now that they're going to be using all of the land below for their combined garden, how much area do the two gardens have together? This is kind of a classic problem talking about the distributive property because there's two possible solutions. Actually, there's probably more ways than just two to figure out the answer, but there's two possible ways we can come to the solution for this answer. And those two ways, we can show how those relate to each other, and that kind of forms the distributive property, how we can go from one expression to the other. Those two ways are both good ways to get us to the answer. Here's one method. One way we could solve this problem to find the area of the entire rectangle is by taking the length times the width of the long side and then the width over there, which is 10 yards. For the longer side, all I have to do is add these two lengths together, though I know that one part is 12, one part is 4 yards. So I would have to add those together to get the total length, and then I can multiply that by the width, which is 10 yards. And that'd be one way I could find the area of that big rectangle. Still the length times the width of the whole thing. Another way I could find the answer to this problem and find the area of both rectangles added together is I could take the area of each individual rectangle and add those together. So in this case, I would take the area of the bigger rectangle here. This would be just 12 times 10. And I'm going to add it to the area of the rectangle, which would be 4 times 10. And if I add the areas of both the smaller rectangles together, I should get the area of the big rectangle. Okay, so again, what we're trying to do, though, is showing that we have these two different solutions, and they seem like two different ways to find the solution, but they both should equal the same answer because they both seem like legitimate ways to find the solution to this problem. 12 plus 4, now solving the problem here and showing that they do equal the same answer, the same number for this problem. 12 plus 4 gives me 16, and then 10 times 16 gives me 160. So 160 yards squared of area that they have to work with for their garden. Over in this problem, 10 times 12 gives me 120, 10 times 4 gives me 40, and this one also equals 160, so 160 yards of area. So good, we've shown that we could solve this problem with either of these two methods. Both of them would work. Well, at its core, distributive property essentially says that we can bounce back and forth between these two methods. I can either take a number like the width here and multiply it by both these things added together, or I can take the width here and multiply it by each one of these numbers separately and add them together. Either of those methods is going to work. And again, in the next few pages I'll show, well, how are we going to use this in when it comes to problems that we're talking about. So I've gone to the next page here, and it looks kind of like the page just before this one where it has the problem with the two gardens. And again, we could say that they're going to have the combined area of both the gardens. So what's the area going to be? But you may notice in this one there is one slight change, is that instead of 12 yards here, knowing that dimension, in this case I only know that it's X yards. It's some number, I don't know what it is right now, but I may be able to find out later. So instead I have X yards. Well, thinking back to how we did the first problem, we had two methods to solve the answer, or to find the answer for this, to find the area of the big rectangle. One way we did it was, the first method was to add, again, the length times the width of the big rectangle here. And I just needed to add these two dimensions together to make that work. So, well, in this case, I don't have 12 here, but I just have X yards. I can still think about doing the same thing, though. It'd be just that number, X plus 4. And then again, that times my width, which is 10 yards. So here's what that would look like. 10 times, well then in parentheses, X plus 4. If I do this problem using the second method, again, instead of having this length here, this 12 yards, I have it as X yards, but I can still think about finding the length times the width of the small rectangle here, or the bigger rectangle, and the length times the width of the smaller rectangle, and adding those two together. So what would happen here? Well, this one would be 10 times X for this part, and the smaller rectangle would be 10 times 4. When we use a distributive property, essentially what's going to happen is we're going to go from one of these two forms to the other. And usually we're going to be going this direction. Not always, but the distributive property says I can bounce back and forth between the two. But usually when we're distributing, what's going to happen is we're going to take a problem like this and make an equivalent expression that looks like this instead, because this one will be easier for us to simplify expressions with or solve an equation with, and maybe we can evaluate it once we find out what x is. So we're going to take something where we have a number multiplied outside of parentheses, like this one, 10 times x plus 4, and we can distribute, as we say, and we're going to change it into this type of problem instead, where I have 10 times x and 10 times 4. What students will see me do a lot when we're doing problems like this where we have to distribute is you'll often see me draw little arrows saying that I can take 10 times x and 10 times 4 separately. And again, if you look at the problem above, that's essentially what's happening here. I have 10 times x plus 4. Well, when I jump over here, essentially what's happening is I just have 10 times x and then just 10 times 4. I'm multiplying that 10 times each of those things separately and still adding it together. So down here in the problem that I'm doing now, okay, if I take 10 times x and 10 times 4, what will I get? Well, 10 times x just gives me 10x. 10 times 4 gives me 40. And so we're saying, again, the distributive property says that this expression is equal to the one we had above. By solving that first initial problem, with the two different methods and showing that their answer was the same, we're showing that it's an equivalent expression to this first one. So when we get an answer like this, after we distribute from a problem that we just done where the 10 was outside of the parentheses, 10 times x plus 4, that's what we're going to look to do to kind of simplify this problem or maybe to even solve an equation. So I've kind of explained it now with the pictures. Again, kind of the idea behind the distributive property. If there's something to copy down, this isn't exactly a definition, but maybe just something to write down about the distributive property. What does it do? Okay, well, it can be used to find the product of a number and a sum or difference. Again, it's where we're taking something multiplied by something in parentheses where we're adding or subtracting it. And so kind of what will this look like when we're doing problems usually in class? I mean, whether it's a word problem or whether it's just some basic problem out of the book. Well, it may look something like this when we're completing some of our problems. I'll have something where I have a number outside of parentheses. Again, it's a product, because this means 3 times whatever I have in the parentheses here, because it's right next to it. So 3 times, well, this is a sum, x plus 2. Again, what the distributive property says is I can take 3 times x individually and 3 times 2 individually, and that'll be an equivalent equation to that first one. It's something that I can do in math and then keep solving the problem with the new expression that I've made. So in this problem, 3 times x, that will give me 3x. 3 times 2, that will give me 6. So the new expression that I'm going to work with is 3x plus 6. And again, an expression like this, maybe we can combine some like terms, or maybe we can solve it if it's an equation, but there's maybe some better options that we have with an expression in that second form than that first one. So that's why we will distribute from time to time in problems. Just walking through some examples together. So this first one says 2 times, well in parentheses, x plus 2. So again, the distributive property, the directions might say use the distributive property. In class, I might say something like I'm going to distribute this to, or we're going to distribute in this problem. And what that means is I'm going to take 2 times x and 2 times 2 and see what I get from my new expression. I should have 2 times x, which is 2x, 2 times 2, which gives me 4. So there's my equivalent expression, 2x plus 4. Number 2, 5 times x plus 3, same kind of thing. I'm going to take 5 times x and 5 times 3 to make my new equivalent expression, which is 5x plus 15. Even if I'm subtracting, it's still the same idea. So that does not change a thing for us in this problem. Again, like it said on that previous page, the distributive property works with sums or differences. So that means it can work when there's adding or, in this case, subtracting inside the parentheses. So 9 times y and 9 times 4. I'll get 9y, and then just minus. I just keep the same sign, but 9y minus, in this case, 9 times 4 is 36. So 9y minus 36. Number 4 here, just a little different, but notice that I do have a negative 6 here. So when I distribute, it's like times each of these by negative 6, and we worked on multiplying positive and negative numbers. So keep those rules in mind when you're doing a problem that has a negative in like this. Negative 6 times n gives me negative 6n. And then there's two ways I can write this second part. I'm going to take negative 6 times 10, and I could think of that like negative 60. So I could write negative 6n plus negative 60. There's also another way you may see this written too in the book or when I'm doing it on the board. If you take negative 6 times 10, this is also equivalent to that, negative 6n minus 60. And just to kind of prove that it's equivalent, if you just chop dash this problem like we worked on in the last section, you can see it's just like plus negative 60. Okay? But I don't even have to do that. I can just leave it as minus 60, and that's also the same answer. So either of those two forms is really the same thing, and both of them would work. Just a couple other examples just to re-emphasize what we're doing here and make sure we understand a few different problems that may come about when we're distributing. This one right here, again, we're distributing a negative 3 to both these numbers. I'm going to multiply negative 3 times y, and then negative 3 times, remember how we talked about just recently, when there's a subtraction sign in front of a term like this, in front of a number or any term, think of it like a negative number. It's like that negative sign, that subtraction sign goes with the 4. Think of it like negative 4, because that's how it's going to work out in the problem. Negative 3 times y gives me negative 3y. And then negative 3 times, well, really like negative 4, give me positive 12, correct? So it'd be like negative 3y plus 12 is what's going to happen there. The two negative signs multiplied together, remember, make a positive. So that's why it ends up being negative 3y plus 12. I just put number 6 on the board to show you that even if the numbers in the back of the parentheses are behind the sum or difference, I can still distribute to both of these terms. 4 times y gives me 4y, and 4 times 4 gives me 16, so this is just 4y minus 16. Just note that also works too, even if the number's behind the sum or difference in the parentheses. And in this last problem, note that we can distribute right here, just like we've been doing in the other problem. So I'm going to take 3 times 2k and 3 times 3. 3 times 2k would give me 6, and then the k would also be with it, so 6k. And 3 times 3 would give me 9. But then also there's this plus 2k at the end of the problem. Well, again, here's one reason why we distribute sometimes, is because after we've distributed, now we can simplify this problem a little more. We worked on collecting like terms just a couple days ago. So now I notice that I have two like terms in this problem, 6k and 2k. If I add those together, I'm going to get 8k. And then I still have this minus 9 here in the middle, so I bring that down with my answer. And there's my final expression. But again, notice how distributing was, but if we didn't distribute, we would not have been able to collect those like terms and simplify the expression. Or again, in the future, sometimes maybe even solve an equation. So this is where distributing can really help us. That last problem kind of shows how we're going to be able to use it in the future. It's kind of a nice tool to simplify some expressions and also to solve equations.